Hi guys, we are ready for lesson 9 of unit 3, Introduction to Adding and Subtracting Fractions and Mixed Numbers. We're going to be able to explore strategies and tools for adding and subtracting fractions and mixed numbers, along with using equivalent fractions as a strategy to add and subtract fractions. Let's warm up. Identify the value of the specified digit. So we're looking at the 5 in each number. So in the first one, we have 152. What would the 5 be worth in 152? Well, when we look at it, we can see it's in the tens place, and we know that if it's a 5 in the tens, that means it's worth 50, because we're only talking about the value of the 5. In 25,893, the 5 is in a thousands place, so our 5 is worth 5,000. And in 962,581, we see our 5 is in the hundreds place, meaning it's worth 500. Our math message today is Dina and her brother are making 2 kinds of bread. Both recipes call for 2/3 cup of flour. How much flour do they need in all? You may use fraction circles or the fraction number lines poster that you can find on the Everyday Math Toolkit to help you. Pause the video and come back. Let's look at some strategies. If you use fraction circle pieces, you would use the different fraction circles with the red circle. The red circle represents one whole. You could use 2 orange pieces to show 2/3 and 2 more orange pieces to show another 2/3. Put 3 orange pieces together would make a whole, and then the total is 1 whole and 1/3, or 1 and 1/3. So you'll see right here in the image, we've got 2/3 plus 2/3. They took one of these thirds and brought it over here, resulting in a whole circle with another third left over. That would give us the answer of 1 and 1/3. Another strategy would be to use fraction number line poster to count up by thirds, or just simply using a number line. You start at 0 and you draw out your thirds. And so you see here we did 3/3 for the ones place and 6/3 for the twos. And you count up 2/3. Okay, so 1 2/3, and then add another 1 2/3. That results in 4/3. And then we need to add on one more third. Nope, I'm sorry. Let's back that up. I messed up. We go 1 2 1 2, and that results in 4/3. And that's the same as 1 and 1/3. I want to remind you of the little trick I believe I've shown you before with the 1 and 1/3 and seeing if it's the same as 4/3. We can have our 1 and 1/3, and we can take the denominator times the whole number, where we would get 3. Then we would take that and add it to our numerator, which would give us 4. And we put that over that denominator, and we should have the same thing there. So 4/3 and 4/3. That's how we can check to make sure our mixed number makes sense with our improper fraction. And again, I apologize for my mess up. Another strategy, thinking about thirds. We know 2/3 and 2/3 is 4/3. It takes 3/3 to make a whole. So 4/3 is 1 whole plus 1 more third, or 1/3 in all. So we can think of that. I'm going to write this out. Okay, we can see 2/3 plus 2/3. Okay, so we're just looking. We know we're dealing with thirds, and that would be 4. And we know that 3/3 equals 1. So if we take out 3/3 from there, do a fair trade, we would get our 1, and then we would have 1/3 left over. So looking back at the estimate, does the answer 1 and 1/3 cups make sense? And how do you know? Looking back at this. Dina and her brother are making 2 kinds of bread. Both recipes call for 2/3 of a cup. How much flour will they need in all? Would it make sense for them to need 1 and 1/3 cups? Yeah. In today's lesson, you will solve more problems involving adding and subtracting fractions and mixed numbers. We're going to solve the problems. And what I want you to do is, as we're working on these, create a number model and make an estimate. We've been practicing with that. We've practiced doing other names for mixed numbers and improper fractions. So now we're moving on to creating number models and estimates. Andre bought 1 3/4 pounds of ham and 2 2/4 pounds of beef. How many pounds of meat did he buy in all? So again, all we're doing right here is creating a number model and making an estimate. So I see here that he bought, and I see this word and, so that tells me that plus sign. And then we have how many pounds of meat did he buy in all? So we have 1 3/4 ham plus or and 2 2/4 of beef. We need to figure out in all. So I'm going to do my estimate because that's what it's asking us. It's not asking me to actually solve. I'm going to round 1 3/4 up to 2. And then I can keep 2 2/4 because I know that that means 2.5. So I'm going to get an estimate of 4.5 pounds of meat in all. That is my estimate. Okay. Hopefully you got the same thing. Monique had 2 1/6 graham crackers. She ate 1 4/6 crackers with her lunch. How many crackers did she have left? So let's take a look at this. We see 2 1/6 graham crackers. She ate. That tells me they went away. 1 4/6 crackers. How many crackers does she have left? So that does tell me this is a subtraction problem. So I'm going to do 2 1/6 minus 1 4/6. So there's my number model. Now I'm going to do some estimating. 2 1/6, I know this 1/6 is closer to 0, so I'm just going to keep that at 2. Minus 1 4/6, that's a little bit, it's kind of close to a half. It's a little bit over, but I think what I would want to do is closer to 1.5 than it is to 2. So I'm going to subtract 1.5. And I know that 2 minus 1.5 is 1/2. So I would say that she probably has 1/2 of a graham cracker left. Here's an example of a strategy for that. Drawing the picture there, okay? We can see you can draw 2 1/6 crackers. Divide the other whole cracker into 6, cross out 4/6, and then cross out that whole cracker, and you'll see that you only have 3/6 left, which equals 1/2. So how many graham crackers did she have left? Does our answer make sense? Yeah, it does. And let's look at this right here. So the pictures and fraction circles, they were useful in solving this problem. I want you to think about why. How were they useful? Why were they useful? Would a number line be useful? How? How would it be useful? These are questions that you can continue to ask yourself as you solve math problems. They're good stopping and reflecting points. Just like we do in reading, we want to do that in math as well. Okay, so let's do this together, and then you're going to do this part. So it's telling us to write a number model with a letter for the unknown, make an estimate, solve. Again, you can use fraction circle pieces. You can draw. You can use a number line. You can use your division. You can use the tricks I've shown you. Whatever strategy works best for you. Now, I want you to know that these are sample number models. They're sample estimates, and the work given is sample because there are different strategies. The answer, though, should be the same no matter what strategy you use. Number 1, Andrea had 1 1/5 liters of water. She drank 3/5 liter. How much did she have left? So we're going to create a number model, an estimate, and then solve. So I'm looking at this and I see that she had, and then she drank. So I know when I have a glass of water and I drink it, the water goes away. So to me, that's telling me it's going to be a subtraction problem. Okay, so I'm seeing 1 1/5 minus 3/5, and I see this. How much did she have left? So I'm gonna do 1 1/5 minus 3/5. My estimate over here, I'm gonna round 1 1/5 to 1, and I'm gonna round 3/5 to 1/2. And so I'm gonna say she has about a half of a liter left. Okay, let's check and see what everyday math says. So the number model they created was 1 1/5 minus 3/5 equals W, because again, we were wanting to use a letter for the unknown. And their estimate was less than a liter. Does that connect with what I estimated? A half and less than 1 liter? Yeah. So you can see the picture here that we have is 2 liters, each divided into fifths. So you see 1, 2, 3, 4, 5. And so we have a whole liter, or 5/5, and then 1/5 here. And what do we have left? 1, 2. Oh, wait, no, sorry. We have this, then we take 1, 2, 3. So what do we have left? 1, 2, 3. We have 3/5 left. Apologize for my errors. Number 2, a table is 2 8/12 feet tall, and a lamp on it is 1 5/12 feet tall. What is their total height? So when I'm seeing one like this, I see the word and I know that means to add, and I see the word total, that confirms the addition. So I'm going to do 2 8/12 plus 1 5/12. So that's my number model. I'm going to put equals T for tall. And we'll compare. And then I want to do my estimate. I'm going to look at 2 8/12. I'm going to round that up to 3. And then I'm going to do plus 1 1/2. And I'm going to get 4 1/2. So I know it's somewhere between 4 and 5. 4 and 5. Let's take a look at the picture and the work that they showed. Okay. So they have the exact same number model. They used H for height instead of T for table, I guess. Their estimate, though, was between 4 and 4 1/2. That would have made more sense because I did have a 4 1/2 here. But this 4 and 5, between 4 and 5, is that logical with this? Because again, these were sample number models and estimates. So yeah, if you had 4 1/2, great. If you had between 4 and 5, that's fine as well. This time they did a number model, so feel free to pause and look at that and ask yourself, what did they do there? And then you can see that they did 4 and 1/12 right there. So now it is your turn. I want you to pause the video and complete problems number 3, 4, and 5. Number 3 is about a chef with 2 5/8 pitas using 1 7/8. Number 4 is about Nico riding a bike, and he rode it for 2 3/10 miles, and then he rode it for another 2 8/10 miles. And how far did he go? And then number 3 is for you to practice explaining in words how you solved problem number 3. Pause your video now and then come back and check. Number 3, your number model should look something like 2 5/8 minus 1 7/8 equals P. Of course, you could use a different letter to represent your unknown, but the estimate should be around 5/8 pita. Okay, so if you had a half of a pita, that would work as well. So again, seeing the sample answer for problem 5 for a sample strategy. Okay, so we will move on to number 5 right now, since it connects to number 3. So let's take a look at how they solve this. So a sample answer for solving this would be showing that 2 and 5/8 with fraction circle pieces. Did you have to use fraction circle pieces? No, this is just an example. Um, Knowing that we didn't have enough eighths to take away, so when we had that 1 and 13/8, we took away 1 and 7/8 and got 6/8. So what they did here was that they turned 2 and 5/8 into another mixed number. And so yesterday in lesson 3.8, we talked about possibly needing to know how to use those mixed number names in order to do subtraction. So you'll see here what they did was they changed 2 and 5/8 to 1 and 13/8, and then they subtracted 1 and 7/8 from that. Okay, so we see we have the same denominator. It's going to be out of 8. We can take 13 minus 7 and we get 6, and then 1 minus 1 is 0. And so that's how they got 6/8. Because when you do 2 and 5/8 minus 1 and 7/8, you cannot take 5 minus 7. So they had to trade or borrow from this to make that 5 larger. And that's where they got that 13. And finally, number 4, Nico rode that bike 2 and 3/10 miles. Then he rode another 2 and 8/10 miles. How far did he ride? You should have that number model of 2 and 3/10 plus 2 and 8/10. They forgot something in their number model. We should have equals. I'm going to put R for ride. Maybe you have B for bike or M for miles. Whatever you want. Their estimate is between 5 and 5.5 miles. And here is their picture they did. They did a whole box for each mile. So there's 1, 2, 3, 4, because we know 2 plus 2. Then you can see here are the 3/10. And then here are the 8/10. And adding those together, we know that if we put the 2 here, then we would have 1/10 left. So that gives us 1, 2, 3, 4, 5. And then that 1/10. If you didn't draw a picture like this, that's okay as well. Remember, every strategy can lead you to the right answer if it is done properly. That is the end of this lesson. Again, this was Introduction to Adding and Subtracting Fractions. So you can probably guess what we're doing next time. We'll probably be moving forward in our adding and subtracting and using those fractions and mixed numbers.